It is a more general framework. Okay. Okay. So before we move on, I want to go through the third assignment with you first. Okay, I forgot to upload it last Friday, but I think go through them can improve our understanding about SDF. Okay, so I want to go through this assignment with you first. Okay, maybe I give you 2-3 minutes to read these questions, and then we can discuss. We can go through them together. Okay. Okay, let's look at the questions together. So in this economy, there are only 3 possible states, okay, omega 1, 2, and 3, and there are only 2 assets. Okay, there's 1 risk-free asset and there's 1 risky asset. Okay, and the risk-free asset gives you 1 in every state, and the risky asset gives you 1.1, 1, or 0.9, okay, in each state. First, we want to show that there are no arbitrage opportunities in this economy. So there are only 2 tradable assets in this economy, the risk-free asset and the risky asset. So we want to construct some zero-cost portfolio with these 2 assets. So what can we do? We can only long one of the asset and short the other one. Okay, that's the only way we can construct a zero cost portfolio. So what we can do is to form a portfolio which is a multiple of R minus RF. Okay, so we buy phi amount of them. Okay, so we're longing phi amount of RF, and we finance our investment by shorting the same amount of risk-free assets. Okay, and now we can look at the payoff. What is the payoff? What are the possibilities? Okay, so there are only 3 states in this world. If the first state is realized, then what do we get? We are longing phi amount of R and shorting phi amount of RF. If the first state is realized, then we get 1.1 from our investment in R, and we lost 1 in our investment in RF. Okay, so what we get is 0.1 times phi. Okay, if the second state realized, then we get 1 from both investment. So we get 0 because we long one and short another. Okay, if the third state is true, then we get 0.9 minus 1. Okay, so we get minus 0.15. So what is an arbitrage? An arbitrage is a portfolio, zero cost portfolio, such that we get non-negative payoff. Okay, and in this portfolio, it is the only choice. The only choice we can choose is phi. Okay, but no matter what we choose, we cannot achieve a non-zero payoff with positive payoff in some state. Okay, so it is not possible for us to choose a phi such that the payoff is non-zero. At the same time, it is positive in some states. Okay, so there is no arbitrage in this economy. We cannot form an arbitrage portfolio in this economy. So this is the first part. Second, describe the one-dimensional family of state price factor. So we want to find the state price. Okay, so how do we find the state price? So first of all, what do we know about this economy? Now we know that there is no arbitrage. It means that there exists a positive SDF. And there are 3 states, but there are only 2 assets. So we know that this market is not complete. Okay? And now we try to find out what the state price is. Because this market is not complete, the state price are not unique. Okay? We do not have unique SDF, so we do not have unique state price. Okay? But still we can try to solve for the state price. So what we have two we have 2 assets here. We have the risk-free asset. Okay? The risk-free asset gives you 1 in every state. Okay, so it is the same as buying 1 of the Q1. We are buying 1 of the Q2, and we are buying 1 of the Q3. Okay, RF equal 1, so the cost is 1. Okay, so the cost is 1. And then we have this risky asset. The risky asset also costs you 1, but it gives you other some different payoff structure. So it gives you 1.1 of the first stage. It gives you 1 of the second state, and it gives you 0.9 of the third state. Okay, so this is how we construct the risky asset and the risk-free asset if the eligible security exists. Okay? So now we can solve for Q1, Q2, and Q3. Of course, there are 3 unknown, and there are only 2 equations, so we cannot solve for the exact value, but we can show their relation. Okay? So we have a Q2 here, we have a Q2 here, we have 1 here, we have 1 here, so we can just subtract the first equation by the second. Okay? Then what we get is 0.1 Q1 minus 0.1 Q3 equals 0. It means that Q1 is the same as Q3. Okay? So state 1 and state 3, they have the same state price. So we can substitute this fact back to the first equation. Then we get Q2 is 1 minus 2Q1. Okay? So any state price needs to satisfy these 2 relations. Okay. We should write it the other way. Q3 equal Q1. Okay, so Q3 is a function of Q1, Q2 is also a function of Q1. So we can just choose any Q1. Then this equation is satisfied. Part C. Describe the one-dimensional family of stochastic discount factor. So we want to find an SDF and verify that this particular factor is an SDF. Okay, so what is an SDF? An SDF is just Q divided by probability. Yeah. So we have this M1 would be just Q1 over the probability. What is the probability? Which is 1 over 4. So we have a Q1 divided by 1 over 4. So we have 4 times Q1. What is M2? M2 is Q2 divided by 1/2. Okay, divided by 1/2. So we have 2 times Q2, and Q2 is just 1 minus 2Q1. Okay, so it is just 2 minus 4Q1. Okay, and M3 is Q3 divided by probability 1/4. So it is 4Q3, but Q3 is just Q1. Okay, so it is just 4Q1. Okay, so this is what the SDF needs to satisfy. Verify that 4 minus 2, 4. So let's say we have an M equal 4 minus 2, 4. Okay, verify that this is an SDF. So we just substitute it back. Okay, we just find a Q1 such that this 3 equations are satisfied. Okay, obviously here we are setting Q1 equals 1. Okay, if Q1 is 1, then we get M1 equals 4, M2 equals minus 2, and M3 equals 4. Okay, so these 3 equations are satisfied, and this is an SDF. Okay, so now here's the question. In the part A, we show that there is no arbitrage, and here we find a SDF that is negative, that can be negative. Okay, so what's wrong here? So we show that there is no arbitrage, and we show that this is an SDF, but this SDF can be negative. Okay. Why? Actually, we already talked about this problem just now. Okay. So no arbitrage implies that there exists a positive SDF. But in this economy, the market is not complete. Okay, so the SDF is not unique. Okay, so there can exist some SDF that the equation, the fundamental equation of asset pricing is satisfied, but it can be negative. Okay, so the no arbitrage condition only implies the existence of positive SDF. Okay, so for example, here if we choose Q1 to be small, okay, let's say if we choose Q1, let's say is 0.1, okay, then what do we get? We get an M which is 0.4, which is 2 minus 0.4, right, which is 1.6, and 0.4. Okay? This SDF is positive. Okay? So this SDF is positive. The existence of this SDF implies that there's no arbitrage. Okay? So remember when we talk about the SDF of cap M, we say that the SDF of cap M may be negative. Okay, but we cannot say immediately that cap M is definitely wrong. Okay, because if the market is incomplete, okay, just that we observe the SDF of cap M can be negative, does not mean that it is wrong. It does not mean that there is opportunity of arbitrage. Okay, it can be because that particular SDF can be negative, but there exists some other SDF that is positive. Okay. Okay. So this is part C. We find that this is an SDF.
So is it okay like we we prove the part A, but like we do all things down to this and we find a specific Q1 because the M here depends on Q1 discrete,
Yeah.
so we can prove like there exists at least one like the SDF that is positive.
Yeah, so you mean you do not do part A, that's what we did. You just
Yeah.
find the SDF and you say if we set
Yeah.
Q this way, then there exists. Yes, you can, of course. They're equivalent. Okay, so this is part C. Part D, we find another SDF. Okay, we consider the projection of y onto a constant at x, then we get this equation. This is a hint. Okay, this is just some projection, and we apply this formula with y being this SDF. Okay, so this is the SDF we are using as y, and then we project it onto the two assets. Okay, we project this particular SDF onto the payoff space. Okay, then what do we get? We get the X star. Okay, we get the SDF which is within the payoff space. We want to see what that looks like. So we want to find this y hat, so we have to get expectation, we have to get this beta. So what is the expectation of R? What is the expectation of the risky asset, risky return? 1. Okay. So we get that expectation, expected value of x here. What is the expectation of y, which is m? Okay, what is the expectation of the m here? So we have 4 minus 2, 4. Okay, so we have 4 times 1/4. We have minus 2, 1/2, 4 1/4, right? So the expectation is also 1. Okay, so expectation of y is also 1. And then we have to find the beta. Okay. The beta is covariance over variance, so we find the covariance first. What is the definition of covariance? Covariance is the expectation of R minus expectation of R times M minus expectation of M, right? And there are 3 possibility. So in the first state, so we get 1.1 from R. So we have a 0.1, okay? 1.1 minus the expectation. And then we have M. M is 4, okay? And then we have 4 minus 1. Okay, and then we have 3, right? And then we have the second scenario, okay? So we have 1. We get 1 from the risky return minus expectation, so we get 0. Okay, so we get 0. And we get minus 2. So we get minus 2 and then minus 1, so we have minus 3 here. Okay, but it does not matter because we get a 0. Okay, then the third state, we have 1/4 probability, and we get a minus 0.1. Okay, and then we get the same as the first state, 3. Yeah? Right? So what is the covariance? 0. Okay, so what is beta? Beta is 0. Okay, so what do we get? What is y hat? This y hat here is the expectation of y, okay, which is m. So we write m hat. It is the projected SDF. We have expectation of m plus the beta times, we have this r minus expectation of r. Okay, and the beta is 0, so we get m equal 1. Okay, so what is m hat? We know that, so m hat is the projection of an SDF onto the payoff space. Okay, so m hat is itself an SDF. At the same time, it is a portfolio, okay, because it is in the space, in the payoff space. So it represents some portfolio. So what portfolio it is? Okay, we always get 1. Okay, it is a constant, so it is just a risk-free asset. Okay, so what does it mean when m equals 1, or when m is a constant? How do we discount asset? How do we discount asset? Suppose we have some payoff, x. We want to price x, okay, some random payoff. We want to price x, so we multiply an m. We take expectation, and then we get the price of x. Right? You know this equation is true. And we can pick some SDF. What do we pick here? We pick an m hat. It is an SDF because it is the projection of an SDF onto the payoff space. So it is an SDF. Okay? So how do we price it? What is m? M is just 1. So it is just the expectation of x. Okay, so the price of x is just the expectation of x. So when does this happen? When does this happen? Sorry? Yeah, it can happen when x is risk-free. Okay, so we do not discount it. But here we have an expectation here. We have expectation of x here. So it is true even when x is random. Okay, so this is true even when x is random. Okay, so even if x is not risk-free, we still price it by just its expectation. So when does it happen? So it means that no matter whether x is risky or risk-free, it does not matter. Right? We are pricing it by its expectation. Okay? It means that risk does not affect the price here. It means that the investor in this economy is risk neutral. Okay? This investor is risk neutral. He's not risk averse. Okay? Because he does not discount the value of an asset by its risk. Okay? That means that this person is risk neutral here. Okay?
Well, can I ask again about the line of the expected of m that is like
Mm-hmm.
like what is the formula for that? Is this like the
It's just the probability times the value. And the value
That's
here
all.
we already give.
okay. Like so can we calculate the covariance in like the expected product minus product of expected, because like that is also true, right?
Yeah? Yeah? That's the same.
It's easier in this case because like the product here
More or
will
less
be
the
one.
same. Yeah.
Yeah, because we have the risk-free set here, so expected of the product in this case would be 1, and on the expected of R and expected.
No, this R is the risky. You mean this is the 1? Yeah, you can do however you want, but it will be more or less the same. Because when you have the cross product, expectation of R times M, right? You have that one, and you are doing more or less the same thing here. Yeah, so it should be the same. Okay, so let's take a break, and at the same time you can read the second and third question.